Hello everyone, Tom Cherry Holmes here with FujiNet test number 13. This is a major step forward because this will actually show that there is a CIO driver being written and that we're actually talking to it and bouncing stuff back and forth through SIO through the CIO driver. Now for this you'll actually see a bit of code. If you've looked at the various firmwares before, this particular test has just enough for the floppy disk, for the virtual floppy disk that's in the file system to load, and an additional command which we call Y, which calls our special little function here, which if we actually look at it, you'll see there's read and there's write, but here is this hello function, which basically sends back, constructs a buffer with a message, sends the message back over SIO to wherever we ask to put it. Now the CIO handler is actually going to put this buffer in page 6 because that's where I've asked it to go. And that brings us to the second part of this. So if we actually look now at the handler, this is the handler. You can see right here, it's got a lot of stubs in it, and we've got a place to put the output buffer. Open, close, get, put, status, but special is implemented here. Special is where all the XIO commands go. And we're currently looking for a command called FE, and based on that, we set up an SIO command to do our Y command, which is our hello command, and to stuff it in the buffer, which is at 0600. We then take and call SIOV, and just to be sure, we take and set a successful, set successful, because this is going to work. It's either going to work or it's not. It really doesn't matter. I could just as easily get rid of the LDY here. But this is a piece of test program. Now of note, when main actually starts up here, it creates a special instance of what's called dev handle, which the CIO needs to take and put into to the handler table so that it knows where our open, close, etc. routines actually need to point to. And they are function pointers. I'm casting them as char so that I can take those addresses that come back from my functions and subtract 1 from them. That's so the pointer math will actually work. I then take and iterate over, find the next available handler table entry, and inject myself into it. Now currently, I'm not relocating the handler or doing anything else. It's loading into a fixed point in memory, which I happen to know can go all the way down to 1D00 on my DOS 2.5 test disk. And with the map file that's generated here, I know that my highest possible address for this binary is 1FA1. So I go ahead and set memlo based on that. I'll need to do something more elegant for that. But once we actually have that and we put it on a disk as autorun.sys, what comes out is something that looks a bit like this. So, an innocuous little basic prompt here, but if I go ahead and do my XIO call, FE is 254, and call it, we see that we return almost immediately. We don't get an error 130 because our handler is there, and it's ready to go. Well, let's extract what it actually pulled up, what it put into memory here. I know how large it is, so I'll just make it like that. Sorry. Typing one-handed sure is a challenge. And with that, we should see our message appear from our buffer. There we go. It's working. So a big step forward. Now we can actually start populating a CIO driver so that we can do more abstracted things, such as opening, closing, getting bytes, putting bytes, etc. But this is a big thing, and I'm actually surprised at how quickly this actually came together, and the fact that I could write the prototype for this in C. I'm sure that I could definitely use some help from experienced assembler coders to take the prototype that I write in C and to write a more efficient version in assembler. If you can help, please try to take and contact us. Thanks.